I just started recording, so go ahead. Sundar will present the device model today.
Uh-huh.
Go ahead.
Okay.
Coco, could you mute yourself? Coco, could you mute yourself?
Okay.
Go ahead. Let's go.
All right, guys, let's get started. Okay. So I'll try to keep this brief, but basically, I just wanted to talk about the way we've been representing devices. So I think we made a lot of progress. We have defined several aspects of how you want to represent devices in Cyborg. But if you look at it, let me see if I can. Yeah. Is it fully visible? Should I make it full
Yeah,
screen or
just
something?
full screen will be good. This is just
Yeah.
in the presentation mode. Yeah.
Yeah, exactly. Yeah. Okay, makes
Yeah.
sense. Okay. So if you look at the core of what we are doing today, we have this mental model, I think, of devices being SRIOV devices. They all have PFs and VFs. That's how things are today. So this is quite appropriate for the devices we have today. So we are saying that if you take a GPU or any of those things, we're going to have a structure, something like what I'm showing here. This is actually what we proposed in the Etherpad in a previous meeting. So if you notice, the main thing is that we are saying there's a certain number of PFs. There's a list of PFs, and they have a certain number of VFs within that, and so on. So this will fit today's FPGAs, but not even all GPUs fit in that model, right? For example, some GPU vendors don't even support SRIOV, right?
Mm-hmm.
Okay. Some like AMD do support it, so we got a mixture of both. And so if you go with SRIOV as the central model, many devices will not fit in even today or in the future. In the future, I would like to take an example of mediated devices because they are going to be substantially different. At the discovery layer, when you first see a mediated device, it's going to show up as a PCI device. So that part remains somewhat similar. But when you attach it to a VM, it will be in terms of a UID that's created on the fly. So essentially, you create a UID, and then you configure the device to associate the UID with one instance of the accelerator. Then you take the UID and give that to the hypervisor like libvirt or something like that in some form, so it can be attached to the VM. So essentially, you're creating new attach handles on the fly. It's not even something which is existing as part of the device when you first discover it, right? So it's not PCI in terms of attach, and it's not even static.
Not static. You mean the addresses could be changing or what?
Yes, in the sense that if you take a VF, for example, when you first discover the device, you know how many PFs there are and how many VFs there are. At the discovery time itself, you know what is there. But in the case of mediated devices, you're going to get a PCI function. Later, when you want to attach that to a VM, you will create a UID. Actually, I have an example of that. We can go into more detail a little bit later too. But basically, you create a UID and you configure the device to create a new virtual instance of the same device and associate the UID with a virtual instance and use the same UID to attach it to the VM. So the virtual instance is getting created on the fly as needed. It's not something which you discovered as part of the device topology itself. I'll get into more detail on this one. But basically, this is one thing we need to keep in mind. The other thing is that even back in the Rocky PTG, people told us that it should not be PCI centric, and I continue to hear that a lot. If you look at all our Nova discussions, there's a lot of feedback from the Power VM guys, and in Power VM apparently don't represent PCI devices using bus device function. Okay, so that's the feedback I'm getting. A lot of Nova interaction.
Excuse me. Yeah, hello, Sundar. This is Shaohe.
Hi, Shaohe.
Yeah, I remember Coco had support MDV devices.
Sorry, who supported again?
Coco.
Coco?
Yeah,
Yeah,
Coco.
but if you look at this proposal here, how would MDev fit in this model, which is in the Etherpad?
She has a submit a patch to support a accelerator type. The accelerator type can be MDV or PCIe or maybe P memory or other types. And the address can be BDF or UUID. Hello, Coco.
Yeah.
Yeah, I
Yeah.
just add a field named interface type in DB DB model, and the interface type is just like Shaohe said. You can it can be PCI or MDV, and the address field can be the UUID or the PCI or PCI address.
So okay, if you're
so
keeping that
it
in
may be
mind,
confused if we use the address to represent all the FPC all the PCI address and the MDV UUID. So I don't know if the address field I don't know how to name it.
okay. So okay, I'm happy that you are keeping this in mind. Can you just go through this and see if we have sufficient level of abstraction to address MDev and also other use cases going forward?
Sure. Yeah. Go ahead. Go ahead. Yep. Keep going.
Okay. Sure. Okay. Sounds good. Okay. So okay. So what I am basically saying is that if we can model the devices using Nova-related abstractions, like which part corresponds to resource provider, which part corresponds to resource class, what is a trait, and so on. And if that is kind of reflected at a fundamental level, it will make it easier to relate to Nova. It will also make it more generic because you could have more complex devices in the future, and it can handle that also. And I think this may not require too much of a change. Let's try to explain that, and you can. And by the way, these changes will be not only the level of the driver to agent, it will also be from the agent to conductor, database. So essentially, it's a Cyborg's model of how devices are represented. Okay. So I think as we already discussed, how do we identify a device? It's not always SRIOV, right? So when you first discover something, how do you identify it? It could be PCI bus device function, but in the case of Power VM hypervisor, apparently they don't identify the device like that. They use their own methods. They have things like location codes, I/O slots, and all kinds of stuff. Okay, so even in terms of how you represent a device and how to identify it in the first place, there could be some differences there. The second level of abstraction would be how do you attach a device to a VM, and that could be a VF, and that could be the MDev, the mediated device. Okay, so this is what I was trying to explain before. So when you want to create a new virtual instance of a GPU or any device which supports mediated devices, the first will typically show up in the sysfs hierarchy as a node in /sys. So you just write the generated UID to that. The act of writing it creates a virtual instance of the accelerator. Then you can take the same UID and associate that with the VM's device. So this is happening on the fly. Yep. Yes?
You guys hear me? Oh,
yeah.
Yeah.
Is that a question? Or? Okay, I'll move on. Okay. So there are also many components per device. So what does that mean? So for example, you could have an FPGA at multiple regions. You could even have a kind of device in the future which is networking enabled. So it's got a networking portion to it and also a FPGA portion to it. So it's a kind of smart NIC or a networking accelerator, whatever you want to call it. It's basically a single device. It could potentially have, let's say, a separate FPGA chip and a separate NIC chip. Or it could have a single FPGA in which one portion is implementing networking and one portion contains some programmable logic in general. So there could be different implementations. But as far as the host is concerned, it may actually see two different things. One is the networking side and one is the FPGA side. Okay, so that's one example. Other one is we have potentially even today is like one device with multiple regions which are independently programmable. So there are many, many variations of that. And each of those components could have their own accelerators. So for example, we could have a FPGA with two regions, and each region contains more than one accelerator. Right? So in our terminology, the accelerators, what can be assigned to a VM.
Can you mute yourself? For folks, don't talk. Please mute yourself. Okay? Thanks.
Okay. Sorry. So this is the general model. There could be many components per device. There could be many accelerators per component. I'll come back to this thing later in the next slide as well. And like we explained with respect to MDEV and so on, the relationship between accelerators and attached handles are not always static. So attached handle could be, for example, let's say VF. We could have a bunch of accelerators in a device and a bunch of VFs, but the correspondence between them is not a fixed thing which is just discovered by us reading the card or reading the device. Rather, when you want to assign something, you may want to configure the device to associate an accelerator with a particular attached handle. Again, I'll explain this more in the next slide, but this is one more thing to keep in mind. The whole area of how we are going to implement networking-enabled FPGAs, I think it still needs to be explored with the Neutron guys. So our NOVA interaction has taken such a long time already. So now you have to start the Neutron side as well. I'm open to all your feedback. So this is a different subject though, so I won't even go into that here, but we can talk about that in the future. And related to the previous point, if you have multiple components like networking and FPGA or multiple regions and so on, you could also have multiple PFs in the same device. So going back a little bit, okay. If you have something like this, if you're listing a bunch of PFs, that's okay, but it cannot be based on just identifying the PF, identifying a device by using PFs. We identify the device generally in terms of components, and associate those components with PFs or VFs or whatever, right? And then there are a lot of other things to consider, like what if the FPGA is not directly attached to your compute node? It could be sitting in a pool. Have you all heard about disaggregated servers, like Intel's rack scale design? Should I talk a little bit about that before moving on?
Yes, please.
Okay. So there is a somewhat new type of server architecture called composable and disaggregated server. The idea here is that if you look at today's servers, you have a certain amount of compute and memory and networking and storage. They're all kind of put together in fixed proportion. It's designed for a particular application category like databases or whatever, right? So depending on what application you want to run, you size your server accordingly. So when you have a data center, you could have a bunch of servers which are designed to run databases. You've got a bunch of servers designed to run web servers or whatever, and that makes it somewhat less flexible. It'll be more useful if you have a pool of compute, a pool of networking devices, a pool of accelerators, and so on, And depending on application's needs, we take a certain number of compute modules, certain number of networking modules and storage modules, and just connect them up. We're composing a node on the fly depending on the workload you want to run. So you can take the same set of components and form different nodes with different ratios of compute, memory, networking, storage, and accelerators. Okay. There are actually a lot of different aspects to it. So if you look at the Intel's rack scale design website, you'll find more information. So Intel is only doing a reference design here, but many other OEMs are already shipping servers based on this concept. So we have to kind of look at how to represent accelerators in pools. You could have a drawer full of GPUs sitting in the rack, which could be composed with some compute modules to create a node. Or you could have a sled full of FPGAs and so on. So how do we represent pooling in our model? And then sooner or later, you have to get in things like accounting, performance management, fault management. There are a lot of different architectural aspects to actually make this a product, which Cyborg can be used in production with all of these aspects as well. I haven't gone to all of those yet, but some of them will have a bearing on even how we represent a device. Like for accounting, we take into account things like when is a device created. So the creation timestamp, the updating timestamp, the programming timestamp, etc., need to be reflected in our model in some form. Do you have any questions or thoughts about this before I go into more detail?
Sundar, so this is Brian from Xilinx. So sounds like what I are talking about, this kind of thing is dynamic reconfiguration, right? So the CPU's memories and all kinds of resources can be considered as resources, and they can dynamically to be attached or detached from the pool or whatever. So you need to have a kind of naming or whatever thing to represent the resources, right?
That's right. You would need some kind of a manager which can take in a workload request and compose a node on the fly.
Okay.
It will say that I need 2 compute modules, 2 networking, and let's say 2 terabytes of disk space, etc. And then all of them get interconnected using a predefined fabric. So the fabric is already present. It allows you to interconnect anything with low latency. So on the fly, you're connecting some compute modules to networking, storage, etc., and creating a virtual node. And then the virtual node, once it's created, you boot a host OS off that, and on the host OS, you can deploy your application stack.
So the devices, then the devices, I mean, the resources are now based on PCI actually domain or whatever.
Can you guys hear me?
Yep.
So I think that the main problem here is, as you said, there will be dynamically spawned virtual devices. Sometimes these are not currently being managed by Cyborg, right? I think that's essentially the problem there, right?
Yes, one aspect is dynamism. The other aspect is it could be non-PCI devices.
Well, I'm not worried about non-PCI devices, though, because our modeling is already handling various different types of protocols. The only thing I see that probably needs some improvement here is the dynamic spawning device that you talked about.
Okay.
So yeah, you can keep going. I assume you have some solution on that, right?
Yes. So this actually has a relatively high level of abstraction, but we can go through that first, and then we can work out the details as we go along.
Yeah, for sure.
Okay, sure. So I tried to create a picture of what we are trying to abstract, right? So in general, in the device, we could say that there are a bunch of accelerators. For example, you could have a GPU with multiple vGPUs. You could have FPGAs with, let's say, multiple instances of gzip or whatever, right? And in addition, you may have one or more components. Like in the case of FPGA, it could be regions, and so on. So these components are depend on the device type and device implementation and so on. There could be just only one of that. But each component will have multiple accelerators, and that's one set. On the other side, we have a notion of attach handles. Actually, before I go into that, I should first talk about identifier. How do you even recognize this unique device? There is some way to do that, right? So we are thinking of PF as the primary way to say that, hey, that's the device I want to identify. Because when the host is going to see a PF, that's what gets enumerated, and you use that as the means to locate the device and identify its components. In the case of Power VM, they don't use the PCI BDF. They got its location code and other things. So the first thing we need to do is kind of have a notion of a device identifier, which is a means by which you identify a device, a unique thing by itself, right? And that could be a PF or a location code or whatever. And then you got a pool of attach handles, right? These attach handles need not be static. That's where the mediated device part comes in. So when you first discover a device, you may only know how many attach handles it can create, but you may not know what those handles are. But if it's a VF, you'll typically be able to enumerate the number of VFs right up front. You'll already know there are 4 VFs in there or whatever, right? So, so you got this bunch of attach handles on one side, and the relationship between an accelerator and attach handle could be fixed, or it may not be, depending on the implementation. So you could have, let's say, 2 regions and 2 VFs, and maybe the implementation just hardwires one region to one VF. So everything is static, just discover that at discovery time. That's one possibility. But it's also possible that you got a pool of VFs and a pool of accelerators, and when you want to assign something, you pick an accelerator, you pick a VF, and you configure the device to associate the two. Right? This model also works for MDEV. So when for a mediated device, you'll come and just configure the device, say create a new virtual instance of the device now. And by the way, here's the UID is the attach handle. And you take the UID as attach handle and give that to the VM. So this model works for MDEVs as well. It will also work for PFs and VFs in a more general case, like I said, where the VF accelerator association is not static. Okay. So one thing which we can potentially add to this model is should we add resources like local memory in FPGA or video RAM and GPU, etc. And they could be at different levels. It could be for the entire device, or it could be per region. In the case of FPGAs, there are many possibilities there. I am not sure if we have any such instance coming up in the near future. So we can add it in the future if you want to. But right now, in the examples are given or in the proposals here, I've not explicitly modeled resources.
A question. So looks like the attach handle is you use the UUID. That is the generic thing. But for some device specific, for example, it really is a VF. Actually, when it is assigned to the VM, for example, we use pass-through. We still use the BDF. So my understanding is some mapping is maintained somewhere between the UUID and the device specific, for example, the BDF, right?
If you're talking about SRIOV device, sorry, was there another comment?
No, that's okay. Keep going.
Okay. So the VF and the UUID are 2 distinct cases, right? If you have a bunch of VFs, you use the VF itself as the attach handle. So the VF's BDF will be used in the libvirt XML snippet to attach the device to the VM. Or you may have a mediated device, no VFs involved, in which case you generate a UID on the fly, and you associate that with a virtual instance of the device, and I associate the same UID with the VM's port for that accelerator.
Oh, so you mean
So two distinct cases.
The handle can be a BDF or UUID, right?
That's right. Yes.
Okay. I thought it's a use the UID, but for a generic UID. But for example, the VF, there's a mapping between the UID and the BDF. Okay. I got it. Thanks.
Sure. Okay. The other main thing to note is that we already have a model to map the Cyborg components to Nova. It's actually one of the strengths of Cyborg because it maps cleanly to the Nova components, unlike the previous model of using PCA whitelist and so on, which is kind of a little bit ad hoc. So we can represent everything, or at least correlate our components to Nova components. So when Nova says, for example, that we need to create a VM with, let's say, 2 accelerators, the call to Cyborg or to OSACC will actually give a resource provider's UID. From the resource provider UID, you have to figure out which device it corresponds to. So if we have an explicit representation of the model saying, hey, we are going to represent associated device level component with some resource provider, subcomponents with some resource provider, accelerators of resource classes, and so on. If that kind of thing is explicit in our model, in database and everywhere else, it will make it easy to translate back and forth. Somebody looking at Cyborg will figure out what's the corresponding Nova component, and when Nova requests come in, we can figure out the corresponding device components based on resource provider UIDs. So that kind of translation back and forth will be very useful. And in the future, maybe it will also help with Neutron, although we need to figure out how exactly we'll do that. So to put it all together, essentially, this is very similar to what we've done before, except that we abstracted some things out. So here's a simplified model of what a device could look like in a kind of a pseudo notation. So at the top level, we have something which represents the entire board. So one of the things we need to figure out is one board itself may contain multiple components, which are independent. Or they may not be independent, they have some shared things like local memory and so on. So how to translate board to devices is something we need to think about. But for now, let's say it's kind of simple. There's one board and one device, right? So we just say that at the top level, we identify the device type, whether it's a GPU or FPGA or whatever. And it's device level data, like whatever information you have, the board or the device, etc. And the information we give the device level data is what Cyborg will use to create the traits for that resource provider. So top level is a resource provider which is nested within compute node, and we can use these properties to figure out the traits to use. So for example, it may things like, for example, device model and all of the things which we had, right, in the specs. We can just, all of that becomes information at this level of the structure. Okay. So then we also include the device ID. The device, by device ID, I mean the device identifier. The identifier itself is abstracted out. So it could be either a PCI or it could be location code, it could be anything. So in Python terms, it's like a object. It's a class by itself, which the instance of the class could be PCI or location code or whatever else a developer may want to use. And then at the top level itself, we have a bunch of accelerators. Maybe there are no components per se. Maybe there's only one component. So we have a bunch of accelerators there. You could have multiple attached handles, board level data, and so on. And potentially there could be subcomponents as well. Like in the case of FPGAs, could be regions, and they in turn correspond to resource providers. So for example, if it's a region, we want to mention the region type at this level of detail. So we can create a region type trait for that resource provider. Then we also indicate how many accelerators there are at that level, and so on. So in a model where the region is tied to a specific number of VFs, the attached handles will go at the level of component 1 and component 2. But in a model where you've got a bunch of VFs or a bunch of regions, attached handles will go in the top level, but the accelerators will go at the component level. Other at assignment time, we'll figure out how to associate the two. So this is similar to what we've been doing before, except that we kind of clearly called out how this translates to NOVA, how this translates to non-PCI, how this translates to mediated devices, and so on. And I don't know if this is too abstract, but here's a particular example to make it more concrete. I hope this helps. So for let's say, I just made up one imaginary one, okay? So this is not any real device, but let's say we got some kind of GPU. We say who the vendor is, the device family. The device family can be used to create a trait. So this top level corresponds to resource provider, and we got enough information to create traits from this one. But the device ID, like I said, is a Python object. The base class is just a generic object, but in the particular case of one card, it could be a derived class like device ID is PCI in this case, and it happens to contain an address. We can even decompose this into bus device function, etc. as such, okay? Or it could be a device ID location code, or a device ID DRC, or whatever the people want to do. But basically, this one object here. And if this GPU contains, let's say, 2 vGPUs inside it, you can say num accelerators 2. And let's say it provides 2 attach handles, which are 2 VFs. This is an example with SRIOV, so it's going with VFs here. So the attach handles, however, is a list, and each one is a generic. Okay, I misspoke here. By the way, I should fix this one. It's not device ID PCI, it's device attach handle PCI. So attach handle is a separate class, and specific examples of it could be PCI, mediated devices, and so on. So if it's a mediated device, we'll actually put a UID in here. If it is a PCI, of course, we've got BDFs, and so on. In addition to all this, the power developers have been asking for something called custom traits, which means that the driver itself can say that I want to apply this trait to this device. So it's something which the driver developer decides. So it could be on a per device or a per device category basis. And then you can include things like timestamps, etc., at this level of detail. So we can, all the previous points we talked about can be brought together in a single structure.
Question, Sundar. So for the custom traits, the specific vendor-specific device can define as many as they want, right?
Yes.
Okay.
Yeah.
So this trait can be consumed by the Cyborg framework. Say, for example, actually, my specific question is for example, for the Xilinx FPGA. I need to create a shell version custom trait. This custom trait must be used by the Cyborg framework to create a, say, flavor.
So my question is the shell version used to place the VM? A trait is something which is known to NOVA, right? It's not a Cyborg concept, it's a NOVA concept. So when you're using something as a trait, it means that you want to schedule VMs based on that. If you only want some kind of property, you can store that in Cyborg as an attribute. But if you want it to be known to NOVA, and you want to place VMs on that basis, that's when you make it a trait.
Yes, yes. That's what I really want. It's a trait. It must be known by NOVA. Actually, when the accelerator or FPGA is scheduled.
I don't think they need to know about what it means, right? They just help them schedule the VM for you.
Right.
They can put the trait in their extra stack or something.
Yes.
I think the idea is for if it is a trait, actually it can be consumed by NOVA. NOVA know its meaning.
Yes. One thing I should clarify is that a lot of these traits have already been standardized. We propose them in the specs, and that should be sufficient for most scheduling. The reason we put custom traits is that people like power, they have power specific attributes and they want to schedule based on that. So for example, they may want to say that schedule only on a particular IO slot or something like that.
Oh yeah, yes. Last time when I looked at your spec, there was not a custom trait. Then I made a comment there. I'm not sure whether you saw it, but I think if there's a custom trait, it's good for me.
Okay.
For that.
We'll include it. But I'm trying to understand your need for using a shell logic type to place the VM. So you're saying that depending on the shell logic ID, you want to place a VM only on certain types of shells, but not others. Is it correct?
Yes. For the shell, for example, even for the same type, for the same FPGA type, there may be different versions of shells. The application is actually built against the shell type is is very important. If the application was built not against that specific shell, it cannot be run on that shell. So for example, if you have multiple versions of shell, you have to provide multiple versions of flavor. Then you schedule it. You have to select that one, that flavor.
Could I ask this question, right? So in the future, if you have one shell with multiple regions, you will actually have to identify each region
not multiple regions. Right? Even for today's FPGA, there's only one region on the FPGA, but two different FPGAs have, for example, we have two FPGAs of the same type, but each FPGA has a different shell version, right? So then we have to have two flavors provided. So when the app is going to be run on a VM, so you have to choose that flavor actually which has a corresponding has a correct shell version, which the application is built against.
Could I ask if this sum 12 is that you speaking?
Sorry?
Who is speaking now?
Okay, this is Brian. Brian from Xilinx.
Okay, so we can we sync up in another meeting also, because there's a lot of things to consider here. But basically, the way it was originally envisioned was that you have a region type. So when you have one shell and only one region, the shell type is equivalent to a region type, right? When you identify the shell, you're also identifying what kind of region it contains. If you change the shell, the region type changes. But that model also scale when you have multiple regions. When you have multiple regions, the shell type alone will not tell you which region
I remember that. Yes, I remember that region type. I also made a comment on the region type, but the format of the region type maybe is not that. We may reconsider the format of the region type. The name is fine. The region type actually, yeah, that meet my requirements. But for our version, we have a vendor specific type, not just the kind of UID thing. It's a very complicated format.
Okay.
So
that's
maybe
fine. It could be a generic string, right?
It's a string, yeah, but it's not a kind of a UUID. It contain quite a lot of meanings in the version.
I see. Okay. Would you like to start a separate email thread or sync up
sure.
another meeting?
Actually,
there are a lot of interesting things to consider here. So if I have not reflected your needs adequately in a spec, the spec needs to be revised because it should work for all of us.
Oh, sure. Yeah. It looks good. Actually, I can talk to you offline. But actually, anyway, yeah, it's good. It's good.
Okay. Sounds good. Sure. But
so
definitely
by the way, so the slides you are presenting, I can access somewhere. Actually, I'm going to drop off my kids to school, so I have to have a hard stop in 5 minutes. So I can look at the slides and talk to you guys later.
Yes, I will send the mail slide.
I send it out the slide a few days ago, right? You sent it.
Yes, I can send it.
Is
I did not have Brian's email address. I have to send it to everybody.
Okay, I'll send out my email address in the WeChat and areas. Okay, later.
Okay.
So, anyway,
Sure.
we can talk offline. Thank you, guys.
Okay, sure.
Okay.
Thanks, Brian. Yeah.
Thank you, Brian.
Okay. So, are there any other comments or questions about?
So my question is, so this is, you're saying this is the report generated by agents, right?
It's part of it is the driver report, and I think if we represent it in the database also in a similar way, it'll give us more abstraction and modularity. It's both driver report as well as what we could store in the database and how we structure the database.
Okay.
So we have a notion of deployable, right? The top level will be a deployable. The components are also deployables, so that part is good. But
Okay.
instead of just having a generic notion of attributes, we could have some standardized things. For example, we could say that associated with the deployable is a bunch of attach handles. So attach handle itself is an object. Device ID is an object. And then some key attributes like maybe device type or timestamps, they're all called out. And then we use the generic notion of attributes for any kind of extensibility. So any additional thing we have which is not standardized, let's go as a generic attribute.
Okay. So, okay, just keep going. I want to see what kind of the change you're proposed to the DB. Yeah.
Hey, Sundar.
Yep.
This is Coco. I want to know the device ID is only have the one address. Oh,
That's a good question.
Identify since the device ID. Does that mean the identifier? So
right.
So it may have. I think it may have multiple address. Since in
If you have,
the
let's say, a device with one PF, that PF's BDF will be the device ID.
Yeah.
But let's say you have a device with two PFs. Then you
Yeah.
have to create a higher level structure in which there'll be two components, for example, and each component will have its own device ID.
Yes, so they're in the same object or two objects. I mean,
I think it will be two objects, right? If you have two PFs, that means you have two of these stuff here.
okay.
And each of them will have
I agree with you.
Uh-huh.
I agreed with two objects. However, we have to represent some kind of interdependence between the two. If there are two PFs coming from the same FPGA, for example, we may have to think about how to program it and so on, right? So you have to represent that the fact that these two PFs are interconnected. So that's an area we need to kind of still think about. It could be a higher level structure than this one. The one component is one level higher.
But my methodology of designing the database at the first place was we have a accelerator table. It tracks the physical existence of the card. So regardless how many PFs or stuff you have on the card, it will have one entry in the accelerator table, right?
First,
so if you have
about, go ahead, yeah.
Yeah, if you have two of this card plugged in the same host, that's two accelerators, and each accelerator have a ID identifier in some case. In some sense, it could be either a PCI address, because they should have a root PCI address there, right? Because PCIe device will be structured in a tree, right? That device should have a root PCI address for representing its identifier.
Yes, I broadly agree with you. That could be two separate trees. The problem will come when these two trees need to be related in some form. If they're sharing something like, let's say, some BMC or thermals or whatever, right? So if you need to represent
you mean those two cards?
It could be a single card with two different PFs.
Even
Huh?
single card with two PFs, then in the PCI, if you look at the BIOS, if you flash the BIOS, you should see these two PFs belong to a root PCI device.
They could be connected to a PCI switch, but that would not show up as a BDF separately, right?
It will not show as a BDF separately, but I mean, from how they structure the BDF, you can see they should be grouped together. They should be in the same group.
Yes, so we can figure out that these two are in the same group. They connect the same PCI switch, or even the PF vendor and device ID should be able to make that out perhaps. But then how do you represent that? They are not two completely independent devices.
They are two deployables, but these two deployables belong to the same accelerator.
Yeah, I just want to know how to map the accelerator, the device to the PF, since in this object.
Before we go further, I just want to clarify one thing. The term accelerator is highly overloaded, right? Different people use it in different ways. But if you look at how it's been used in NOVA and other places, we use the accelerator as the name for the resource class. So it's not the whole device. One device contains multiple accelerators. That's why I say there's custom accelerator FPGA, custom accelerator GPU, and so on. And I said how many of them there are per device. So just to be clear about the terminology you're using, so one device contains multiple accelerators. Okay.
I know what you mean by the accelerators, but in terms of our database namings, right? Accelerator is the physical existence of the card. That means if you have one card in the plugged into the PCIe slot, and then regardless how many PFs, VFs that it spawns, right? It will reside in the same group from the BIOS perspective.
Right.
Yeah. So in that case, the vendor driver should easily figure out that okay, these deployables are belong to the same accelerator.
So you have two separate deployables, each associated with a single PF. Would you create a higher level deployable to contain the first two? Or would you simply put some pointers from one deployable to another?
You can do like, because with PFs and VFs, they are deployables, right? They're still deployables.
So that's what I think we need to change, I think, Liu. So I think the way we are doing it, like if everything becomes just an object, it doesn't reflect the structure, right? A deployable would be something, at least going by the meaning of the term deployable, it will correspond to some component here. So either a top-level component or one of the sub-components like regions, right?
Yeah. Yeah,
whereas something like attach handler, a device ID, etc., they would not be deployables with themselves. They are something we use to identify what is deployable.
So those should belong to one of the attributes in deployable, right? Like the identifier there is just attributes.
So I think that model is not fitting this kind of approach, right? Basically, we want to abstract things out and represent different things like device identifiers and attach handles explicitly. So I know what you're saying. That's what we have today. I'm just saying that if we think in terms of this model, our database will also be kind of a little easier to understand, because fitting everything into just three things like deployables, accelerators, and attributes could be more constraining. If you have an explicit model like this, you can say that deployable corresponds to a component, device ID corresponds to that thing, etc. We'll have a clear picture.
I still don't quite get it. So could you show us the what kind of the database change you will have?
Okay, sure. That's fine. Okay.
Yeah.
So this is my proposal. Of course, you're welcome to comment upon that. So basically, the class deployable still exists, but it corresponds to a component. So every deployable has a UID. Here's my mouse. Can you see my mouse pointer?
Yeah, I can.
Okay, good. Okay. So you got a UID, you got a parent UID, root UID. We got a hierarchy just like before, except the deployables now represent these components over here. Like if you go here, it's either a device or each component. Or in terms of this model, it's one of the levels in the hierarchy. Either top level or whatever, and it typically will map to a resource provider in Nova, but doesn't always have to do that.
Mm-hmm.
Okay, so we got that. Then you got ways to identify how many accelerators there are, how many attach handles there are, and so on. And attach handles themselves form a separate table. So I did have an example of that. Actually, before I go to attach handle, let's look at device ID, right? Okay. So one type of deployable is a root deployable. It's a top-level thing. And only the top-level thing has a notion of a device identifier, device type like GPU or FPGA, and specific things which are common to the entire device.
I have a feeling the root deployable is kind of redundant here because first of all, our accelerator table can serve the purpose. The other thing is just another. If you just want to keep another deployables as a root in the tree structure, you just use another deployable, and all the other children just have a pointer in their root UID, and that's it, right?
So if you look at this root deployable, it's also a deployable only. Child class.
Yeah.
So basically, whatever specific only to the root, which does not apply to the children, will go in here. For example, things like the type of the device, GPU or not. You will not have it one per child, right? It's only for the entire thing. Similarly, the vendor, device family, a bunch of things should apply only to the top level. That's the reason to have this decomposition.
Okay.
And the device ID itself is another table. So there are different device IDs. Like for example, you could have just a base class, which could be anything at all. You could have a PCI device ID, which contains bus device function. And the power guys could create their own device ID classes, like location codes or whatever they want to do. But they're all represented uniformly. The root deploy will simply say, I've got a device ID, and I'm pointing to that. So it's like in SQL alchemy, it's a hierarchy of classes, and you're using objects to represent each portion. And similarly, if you've got attach handles, it's from its own class hierarchy. There's a base class. And for every type like PCI or mediated device, you've got one child class. So SQL alchemy allows us to map the Python object hierarchy to database tables, right? So if you have that thing, both our code and the database are in sync.
Okay. So the device ID and the other things, I mean, I'm fine with that. So essentially, you're just adding another object called root deployable. And having this, you're giving it some extra fields. Right. That's all.
Right. That's one thing, and we called out attach handle as a separate object, device ID a separate object, right? The device type could be explicitly modeled as some kind of an enum in SQL alchemy terms. So we've got specific categories of device types. And basically now we also have this notion that a deployable corresponds to something in Nova usually, right? Like corresponds to resource provider. So you can associate things like resource provider UID etc. with the deployables.
Mm-hmm.
So with this model, like it can represent everything using this. We don't need a separate accelerator stable. I kind of did not understand even earlier why we need that thing. I think your idea was to keep it for the entire device, but a root deployable represents the device, right?
Yeah. I kind of really want to work on that one. Drop the accelerators table. Yeah, that's causing a lot of problems.
Maybe the same concept is already present here. But when you say accelerator stable, it's stable for one per device, right? But you already have one. The root deployables essentially give the same information, isn't it?
Yep.
Anyway, you can think through it. I mean, we don't have to settle this right now.
I think looking at this, I kind of get what you're saying. Yeah, I kind of get what you're saying. I need some time to consume. Yeah, I kind of totally get what you're saying.
So the root deployable is similar to accelerators.
Yeah, it's similar to accelerator. It's very similar to accelerator. But it kind of keep the structure simpler by not having another table. Yeah.
That, and personally, I found it confusing to call this accelerator, and in Nova, accelerator means something else.
Yeah, I totally agree.
Correlated was a little difficult.
Well, the reason I had a accelerator table in the first place was someone put it there. I don't want to change it. That's it. I totally agree with you. I totally agree with you on that. Yep. Okay.
Okay.
So how do users know if they ask the Cyborg, how many cards have I inserted into a PC or into my cloud? And so
Well, you just count the number of root deployables, right? That's the number of cards you have.
yeah.
Exactly.
Okay.
Right.
Yeah. Well, when you map this one back to the deployable table, probably you need. Okay. Yeah, you don't need that. Okay. But you probably need to add some extra, for instance, the device ID. Yeah, we'll talk about the implementation details later on. Yeah, I don't want to bother you. Yep.
So, by the way, Lee, you may have a point that you could have a card with two separate chips and two separate PFs. In that case, each PF will be associated with a different root deployable. Then you could ask, how do you represent the card as a whole, right? So that may be a separate structure.
Well, I mean, in my opinion, why not just make the card a root deployable, but those two physical separated circuits as another deployable associated with it?
I agree. I totally agree.
It's like there's no harm doing that, right?
Yeah. The only
don't
thing
make
is,
things too complicated. I just want to, as far as explaining to others, I will just say, okay, the root deployable is just a replacement of the accelerator we had before.
Right. But if necessary, you could even create something like a table for boards, where one board contains multiple root deployables, or something like that. I'm just throwing an idea out here. If we need to show that, for example, these two root deployables share some memory, for example, or they have same thermal constraints. They're sharing a BMC. Yeah. Anything at that level could be a separate table, or you could have one root deployable pointing to another as a sibling. There are many ways you can do that.
Okay. Yep.
Yeah, so you guys can think about it. There's probably a lot of information in one shot. So I'll share the slides with you. So please do give your comments and your feedback. And we can probably even take this to the PTG if you guys are interested.
Yeah, please. Yeah, you're welcome.
Yep. Yep.
So that's it.
Yeah, that's all I have. Yeah. Yep, that's it.
Okay.
So basically, everything is right there on the slide. So I'll just send this to you. I'm going to make one change to the slide because I have a mistake here. Attach handle should not be device ID PCI, it's device ID at device attach handle PCI. So I'll kind of fix the typos here and send it out.
Okay.
Yep.
So, yeah, could you fix that and then send it to everyone, including Brian?
Yeah. How send it to you guys? How do I send it? OpenStack Dev?
Well, you can send it to the OpenStack Dev, but you can send a separate email as well as with the attachment.
Sure. Yep, I can do that.
Or if you can put it on Google Drive, let's see.
Yeah. Sure, I can put it on Google Drive. Yeah.
Okay. And then put a PTG discussion topic in the Etherpad regarding this. Yeah.
Yes, I'll add it to the Etherpad too. Okay.
Yeah, I don't know. Probably won't be able to make to the PTG. But I will dial in for that. I hope Howard can be there. He probably can. Yeah, he probably can be there.
Oh, I didn't know you were not coming. Okay, I see. So sorry, who's coming in your place?
I think Howard is coming. He's not decided yet, but he probably 70% chance going there.
Me and Zheng Hao will go.
Okay, nice, good. Hope to see you all there.
Shaohe, is Shaohe coming?
I think Dolpher is coming, if I'm not wrong.
Dolpher?
Shaohe,
okay.
Yeah, Dolpher Do is coming, if I'm not wrong. And I think Shaohe is coming to some future event, right?
I will not go to PTG. There's no magic for me.
Okay.
Yeah. Dolpher will go. I'm not sure. Jian will go.
I'm probably not coming.
Okay.
Sundar, do you want to explain the
Sorry. I can't hear you clearly, Shinra.
Yeah. Do you want to explain the power architecture supporting Cyborg to the community as provided last week?
Okay, I mean, it's not any different from what I already said. So basically, the power guys will implement their own implementation.
Yeah, could you mute yourself? It's very noisy on the side. Thank you. Sundar, keep going. What did you say?
Okay. So in the case of power, the only abstraction would be that they'll have a different device ID and they'll have their own attached handle.
Okay.
So that's, yep. Okay.
Keep going.
So apparently a lot of stuff is different. Hello, is somebody raising a question or is it a side talk?
No.
Okay. Shindra, to answer your question, power will represent the device ID and attached handles differently. And apparently in the workflow, many other things like taking a PDF and putting it in XML, they used to do it using REST APIs. So many steps they'll have to call into some REST API server to get the attach done.
Okay. Sundar, the question I have right now is is regarding the spec you submit. It's about the spec you submitted earlier. So I think the most important thing is right now is to can you provide a spec on the Nova side to guide what they should be changing in Nova to interact with us, and then get them agree on that one.
Yes, Lee. So that OSACC spec is meant to do that, right? We already have.
Yeah, but it's cyborg space, right? Oh, I mean, because there will be some changes on the Nova side as well. They need to know what they need to change, right? Because right now I think if they agree on what they should change on the Nova side, that's all. That's all good for. That's all we need from Nova guys. I mean, and then we can design our OSACC spec on our own, right? As long as we work with that one there. I don't want to involve them so much on the spec in the cyborg space, because this is just going nowhere. It's going forever.
I understand. Yes, I understand.
Yeah. So I think the strategy is we propose something in their land, ask them to change their code accordingly, and then we design our stuff interact with that one, with their stuff, with their change. And the design, this is all depend on us. We don't need to involve them that much.
So apparently that's not the way it works. So if you look at OS with, hello, can others please mute themselves? It's very loud. I can't hear much.
I don't know who's.
If you're not talking. Yeah. Thank you.
Is it Xiran or Xiran? You're not muting yourself. Could you mute yourself? Okay.
Okay. So if you look, see, the OSACC is supposed to be similar to OS WIF, right? OS WIF is jointly maintained by Nova and Neutron. So even even for OSACC, they're saying it will be some kind of interface library with the input from Nova and input from us. So a lot of discussions going on because we want to keep that generic. So the Nova Works drivers will change only minimally, just to call into OSACC, the same way it calls to OS WIF. And the problem now is how do you design the OSACC workflow to work with Cyborg? So I understand it's taking a lot of time, but it's going to be difficult to say that we'll do OSACC by ourselves. You just give me the Nova Word interface. Many of the other people in the community may not accept that.
Well, but at least I think we should propose something in the Nova, ask them to make the change. Because I think that will also take a lot of discussion. If it's a small change, we just propose it first, just to get our head in there and start a conversation.
Lee, if you don't mind, can you please mute the person whose name shows up as Pro? That's where the noise is coming from. Otherwise, I can't hear you. There's something called
I think it's Shahe.
Pro.
Yeah, that's Shahe. I don't know how to mute him. I'm on my cell phone. Shahe.
Yeah. Okay.
I don't know how to mute him. Is there a way to mute
I understand what you're saying. We need some changes in Nova. That will in turn depend on how we agree on the Nova to OSACC interface.
Okay.
So that's the problem. So we're getting tons of these comments.
Yeah.
We
and the other thing is, the other thing I think is just some people just dump whatever they're thinking into the review. We just, there's no way we can make everyone happy. I think at the end of the day, we just come up with some compromised version of it, and just there's no way we can just make everyone happy. I mean, we just need to stand our own land and I hope like in the PTG we can have some more discussion to finalize this stuff.
Absolutely, yes, yeah. Sure.
Yeah, in the PTG, for the Nova discussion, I think, are they coming to the Cyborg session to discuss with us, or we go their session to discuss?
So I'm not even able to reach them because many of them are very busy. I've been proposing that we should have some kind of a session with at least the people who are showing interest in Cyborg. So I think we need to probably get together and propose a session at the PTG.
Okay. Let's do
write
this.
Eric.
I could propose a session slot in the Cyborg space, and then send out an email in the community saying, okay, we're gonna discuss this in Cyborg session. It's welcome anyone interested to come. And then I probably will contact. So what happened?
Sure.
Hello.
Hello. Yeah. So Lee, if you're available, maybe you should also sync up offline to discuss the process of PTG and such. So right now I need to drop off for the next call, but we can be in touch.
Oh, yeah, we should. Yep. Okay.
Yep.
Okay. So, yeah, well, I'll catch up with you on that. And
sure.
So that's it for today's meeting then.
Yep.
Anyone else has any other questions or topic to discuss? Okay. So I will call the meeting. Thank you, guys. Thank you, Sandra.
Thank you.
Thanks, Lee. Thanks, everybody.
Yeah,
Bye.
have a good night or good day, whatever you are.
Good day. Have a good day.
Yep.
Bye.
Bye-bye.